Hi everyone, today we're going to study the ellipse with center at origin and vertex on y-axis. Let us first define ellipse. An ellipse is the set of all points in a plane such that the sum of its distances from two fixed points in the plane is constant. The fixed points are called foci, plural of focus, of the ellipse. Here we have 2 points arranged vertically. And we have the ellipse here. The line through these two foci is sometimes called focal axis. This is the line. The point on the focal axis midway between the foci is the center. In our figure, this is the center. The points where the ellipse crosses its focal axis are the vertices. We have 2 vertices. This is the first and this is the second. The line segment joining the 2 vertices is called major axis. This line segment in red is the major axis. The line segment through the center perpendicular to major axis terminating at the ellipse is called minor axis. This line segment in green is the minor axis. The eccentricity denoted by E of a curve tells us the amount of roundness of that curve. Take note that eccentricity of circle is 0. The eccentricity of parabola is 1. The eccentricity of ellipse is between 0 and 1. And this is the symbol that we will see in the books. Remember, a small eccentricity indicates that the ellipse tends towards being circular, whereas an eccentricity close to 1 indicates that the ellipse is elongated. Let us see an ellipse with center at origin and vertex on y-axis. Here is the ellipse, the center at the origin 0, 0. Let us plot the vertices, and the first one is denoted by V, while the other is V prime. Take note that the vertices are the points where the ellipse crosses the y-axis. Remember that the line segment connecting the vertices is called major axis. If we assign the value 2a for the length of this line segment, we can now write the coordinates of the vertices as 0a and 0, negative a, respectively. Let us plot now the foci. The first focus is here, denoted by F, and the second focus is F prime. The line segment connecting these 2 foci is assigned to be 2C. And then we can now write the coordinates of the foci, and these are 0C and 0, negative C, respectively. Now let us assign 2 points B and B prime here, and these are the endpoints of the minor axis. the line segment is assigned to be 2b. It means the coordinates of the points B and B prime are B0 and negative B, 0, respectively. Now let us take one point of the ellipse. Let's say this point in red, denoted by P with coordinates xy. This point P here represents all the points of the ellipse. By definition of ellipse, the distance between this moving point from the first focus added to the distance of this moving point to the second focus must be constant. Now, the standard equation of the ellipse with center at origin and vertex on y-axis is here. X squared over b squared plus y squared over a squared equals 1. The derivation of this equation is presented in the other video. Now, the latus rectum, and we have two latera recta here. The length of each latus rectum, denoted by LLR, equals 2b squared over a. It means to say, if we're going to look for the endpoints of the latus rectum respectively, so the first latus rectum will have the coordinates plus or minus b squared over a, comma, c. Here are the points. The other endpoints of latus rectum have the coordinates plus or minus b squared over a, comma, negative c. These are the points. For the eccentricity, we use the symbol E, and this is equal to c over a. Now let us see this example. Find the vertices and points of minor axis, foci, eccentricity, length of latus rectum of the ellipse x squared over 36 plus y squared over 64 equals 1. Sketch the graph. For our solution, take note that 64 is greater than 36. Thus, we say a squared equals 64 and b squared equals 36. We can solve for a and b respectively by taking the square root of each equation. So a equals 8 and b equals 6. Take note also that the bigger denominator is on y squared. It means to say, this is an ellipse with center at origin and vertices on y-axis. Take note also that a is the distance from center to vertex, while b is the distance from center to one endpoint of minor axis. This is now the ellipse. Let's start writing the coordinates of the vertices. These are 0, 8 and 0, negative 8 respectively. Letter B, the endpoints of minor axis. The coordinates are 6, 0 and negative 6, 0. Next are the foci. Let us solve for C using our Pythagorean relation a squared equals b squared plus c squared. Substituting the corresponding values, we have 8 squared for this a squared equals the b squared is now 6c squared plus c squared. Simplifying this, we have 64 equals 36 plus c squared. We transpose now the 36 to the left side. This is now 64 minus 36 equals c squared. And the difference is 28. Taking the square root of this equation, we will get the value of c equals plus or minus the square root of 28. It means to say the coordinates of the foci are 0 square root of 28 and 0 negative square root of 28. These are the points. Now the eccentricity is denoted by E, and this is equal to C over A. Substituting the values, the C is the square root of 28 over A, which is 8. Let us simplify further. The square root of 28 can be written as the square root of 4 times 7. The number 4 inside the radical can be taken out into 2 times the square root of 7 over 8. We can cancel the constant 2 and the denominator 8, and we have the final answer to be square root of 7 over 4. This is the eccentricity. Next is the length of latus rectum, denoted by LLR. This is equal to 2b squared over a. Let us substitute the values. We have now 2 times 6 squared all over 8. Let us simplify the numerator, and this is equal to 72. And the quotient of 72 by 8 equals 9. This is now the length of latus rectum. And these are our final answers. I hope you learned something from this video. See you again next time.